Hi there, this is Penelope. This is a video on projectile motion, and it involves obviously gravity. Gravitation is a force that's in effect all the times in our daily lives. Newton developed an understanding of gravitation by considering why an apple falls to the ground. He proposed that all objects in the universe attract one another, with a force that he called gravitation. In particular, he thought that gravitation was the force that keeps planets in their orbits around the sun and keeps the moon orbiting around the Earth. Gravitation is always attractive. Other forces can be attractive or repulsive. If you think of magnetism, for example, it can be attractive or repulsive. Acceleration due to gravity is fairly constant over the Earth's surface and for some kilometres above the surface. As far as we're concerned here, a standard approximation for gravity would be 9.8 metres per second squared. 9.8 metres per second squared. If an object's thrown vertically upwards or dropped downwards, it'll accelerate downwards at a constant rate of 9.8 metres per second squared. Here's an example where we've got a cliff. It's 50 metres high. And we've got gravity as 9.8 metres per second squared. And we need to draw a graph to find what we're looking for. We can draw a velocity time graph and mark off seconds. 1, 2, 3. Oops, wasn't meant to have a wiggle. And the slope of that line is going to be 9.8 metres per second, because for every second it's going to increase or decrease 9.8 metres per second. So what we've got to do is to find the area under 1 second, and would use just the area of a triangle. So the distance then would be a half times 1 unit times 9.8. This will give us the answer for question A. That's 4.9 metres. And for question B, it's going to be for 2 seconds. So the distance would be a half times 2 times 9.8, which would be 19.6. It's just a little bit wonky there. This should be 9.8 times 9.8, 9.8 plus 9.8 in the 2 seconds, so that'd be 19.6, which will give us approximately 20 metres. Now, how long does it take to fall 50 metres? Well, we need to use one of our equations, and we'll use the one that says D equals VIT plus a half AT squared. So we found the distance. We know it's 50 metres. We know that our initial velocity was 0. And we know that our gravity is 9.8. We don't know what T is, so we can rearrange that to tell us that T squared is going to be 50 over 4.9, which is, well, then we can find that T is approximately equal to 3.2 seconds. So we had to use the equation. It was a bit too tricky to get from the graph for that one. Now, a ball thrown upwards, initial speed 20 metres per second. Questions then, how far does it rise in 1 second? How long does it take to reach the highest point? And how high above the ground? Now, if we are given the graph, if we're given the function, so that it's like that, and we're given this information, and so we know from the previous example that'll be 19.6 and that'll be 9.8. The slope again is 9.8 metres per second. How far in 1 second? It'll be the area under the curve. And that'll be, now it's a trapezium this time, it's this bit here, and you might need to look up to see why I'm doing this. It's the 19.6 plus 9.8, so it's the average of those two times the width, which will give us approximately 15 meters. So that's the how far in 1 second. How long to reach the top? Well, it's going to reach the top when the velocity is 0. And we can see that that's this point here, so we can just read off that t is 2. The highest position is when the graph goes to to t equals 2, and then we need to again find the distance under the graph. The area under the graph would be 1/2 times 19.6 times 2, which would give us about 20. Now, a projectile is any object that moves through the air without its own source of power, for example, a bullet or a shot put or a netball. Is a rocket a glider a projectile? No, because a rocket actually propels itself as it moves along. It's expelling gas. And for a glider, the motion of the air over its wings is actually causing it to lift, so that can aid its motion. Another important force that acts on projectiles is the air resistance. Now, this force isn't constant because the size of the air resistance varies with the speed of the projectile, so mostly for the sake of simplicity here, we assume that it's negligible. Okay, now some maths. The position and acceleration of a projectile at equal time intervals can be drawn out as a parabola. So that's a shape like that. So we could draw constant downward acceleration. And some of the things that we know about the parabola, because that's the shape that it draws out, is that the velocity that it takes off at is the same velocity as it comes down at. The angle that it goes up at is the same as the angle that it goes down off, because parabolas are symmetric. That means that the maximum height is there, so that this distance is the same as that distance. The motion at the top is momentarily horizontal. Momentarily it stops. So now using that, we can do some work. This one, we've got that the vertical speed is 10 meters per second and that the horizontal speed is 20 meters per second. And we need to find the distance, which is from here to there. Right, at the maximum height, then we know that the vertical speed will be 0. So at that stage we use this formula. We know that this is 0. We know that the initial velocity vertically was 10. We know that gravity is going to pull it down at 9.8 and it's going to be t. We can rearrange that mathematically to say 9.8 t is 10, so t equals 10 over 9.8, which is approximately 1 second. So it takes twice that to reach its maximum, to reach the end. So that would be 2 seconds. So 2 seconds to go all the way. The distance then we can find by d equals vt. We know that the horizontal distance, the horizontal speed rather, is 20, and we know that it's going for 2 seconds, so that we know that it travels for 40 meters. So this is the range that's asked for in this question. We've got a softball that's going up at 40 meters per second at an angle of 40 degrees. Now let's draw this in a triangle, a right angle triangle. So we've got our velocity, and our trigonometry would tell us that and that. So the initial vertical speed is v sine 30, which is 40, tells us that, times sine of 40, because that's 40 degrees in there. And we can use calculators to work that that is 25.7 meters per second. At the maximum height, the vertical speed will be 0 because it stopped going up. So we can use Vf squared equals Vi squared plus 2AD. Now we need to find, we're asked to find the maximum height, how high. So we need to find D. We know that the vertical height, the vertical velocity is going to be 0, and we've just found the initial one as being 25.7 squared plus 2 times, now it's coming down again, so it would be negative 9.8 times the thing that we don't know, and we can use some maths to find that that's equal to negative 25.7 squared over negative 19.6. Do it all at once in your calculator and you get that it's approximately 35 meters high at the highest point.